Radhe Radhe. So in this video, I'm going to discuss the chef product problem which occurred in today's code chef challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I'll provide both the links in the comment section. I'll pin them. So the problem statement is very simple. You're given a number n, and you have to find the number of distinct sizes of subsets, such that every subset should have, like, all the numbers should be odd, because it is given that the product of any subset of that subset is going to be odd. So that is basically all the numbers should be odd and all of them should be distinct. So for 4, there is only one possible, that is 1 and 3, or like there are others also, like 3 and 1, something like this also. But the thing is, we have to find the number of distinct sizes, so only a size of 2 can be possible. Okay, clear? For 18, you can go for a size of 2, that is 1 comma 17. Of size 3, there exists nothing, because of size 3, if all the 3 are odd, so odd plus odd plus odd is odd, and 18 is an even number, so you can't go for it. And for size 4, you can go for 1, 3, 5, and 8, 9. So you can go for 9, right? So this is of size 4. And obviously for 5, we can't have any, but for 6 or greater than anything, we can't have any. Okay, it is very simple. So how we are going to do is, we have to consider the greedy approach, that is 1, 3, 5, 7, 9, dot dot dot. That is the sum of first n odd numbers. So remember one thing, sum of first n odd numbers is equal to n squared. Okay, so you know this, like the triangle thing. Okay, there is a triangle thing which states that sum of n odd numbers is n squared. So whatever it is. So over here, we are provided with the n squared values. Okay, so how we are going to find n? So let's say this is n. Okay, now for less ambiguity, let us name this as capital N. Okay, capital N. So this is n, so, and every n is equal to capital N squared, right? So how we are going to find n? It is going to be square root of n. So once we have done with the square root of n, now we have to do some checking. That is this type of checking, that is whether the number is odd or not. Okay, so if we get this n, so n is basically the maximum size of maximum size of set that is possible. Okay, now remember one thing, if the maximum size of a set is even and n is odd, then that is going to provide us with some ambiguity. Okay, because let's say there are like even number of elements, so even number of odd numbers, if we add them, it becomes even. So n should be, so that is n mod 2 should be equal to n mod 2. Okay, clear? So if it is not equal, so what we can do is make n minus minus, so that it becomes equal. And once we are done with this, so we can say answer is equal to n plus 1 by 2. Why is it n plus 1 by 2? Because if we check it, that is if n, so let's say the maximum size, what is n? The maximum size. Sorry. So if the maximum size is 5, so we can go with 1, 3 and 5. If the maximum size is 6, we can go with 2, 4 and 6. Similarly, what we can see, that the formula is basically n plus 1 by 2. Okay, capital N, right? So what is the basic thing? N is equal to square root of n. N mod 2 is, if n mod 2 is not equal, if it is equal, then no problem. If it is not equal, then you have to perform this n minus minus, and then answer is equal to n plus 1 by 2. That is the answer. That is the basic thing. Now remember one thing, now whatever I'm going to see now is the most important part of the whole thing. That is, if you're going to find out square root using SQRT, the last test case is not going to pass. Okay, like I've been seeing that even it happened with my case, that the last test case was not passing. So for this, you have to use SQRTL. Okay, clear? That's it from my side. Thank you.